All right, guys, graphing the tangent function. Let's take a quick look here at graphing the tangent function. The good news is that if you remember a few key pieces of information, you're going to be just fine when it comes to the tangent function. So for starters, I'm going to cross this out. We're not too concerned about the cotangents right now. Okay? So if we're looking at the tangent function, remember what tangent actually is, what it represents. It's the sine divided by the cosine. So it's the y term divided by the x term within a coordinate. So when I'm looking at the unit circle and I want to evaluate the tangent of 0, we take the y divided by the x. 0 divided by 1, no problem, we get 0. It's when we go over to tangent of pi over 2 and we try to take, here, the y term divided by the x term, 1 over 0, that's going to be a problem. Okay? Like, you can't do it because it's undefined. So if we were to test tangent of pi, we get 0. Tangent of 3 pi over 2, we again get undefined. Tangent of 2 pi, we're back to 0. So graphically, what happens when we're undefined? I guess what I'm asking, on a graph, what happens when you're undefined? What do we draw? We draw a vertical asymptote. So, yes, tangents are going to be a little bit different than the sines and the cosines, of course, because we have asymptotes. So, again, we have to stay away from those asymptotes. Is it mandatory that we draw them in? Absolutely, it is mandatory that we draw them in. They are part of the graph. Okay, they're part of the overall curve. Okay, so a few things to know, and I know that we touched on this a few minutes ago, but tangents do not have amplitude. Once again, if you're asked to identify the amplitude of a tangent curve, you say it's undefined. It does not exist because the parent function for tangent looks like this. It already goes from negative to positive infinity. So if we stretch it vertically, you're going to have a hard time convincing anybody that you're stretching it to more than infinity. Because that's not a thing. That's not real. Okay? We are still going to use the absolute value of A for our frame. Vertically, we have to build that frame, and we have to go up and down a certain amount. That's still going to be the absolute value of A. So again, only sine and cosine have true amplitude. The other thing that's going to be worth mentioning here is that the period for tangent or cotangent is now pi over b, as we talked about before. Not 2 pi over b like sine, cosine, secant, cosecant, but it's just pi over b. All right, so if you recall, I know this is going way back to January, but if you recall what we focused on as being really important with the tangent curve, again, we wanted you to remember a couple things, and that is, number one, that a tangent curve is always increasing, and it goes through the origin. So as long as you remember that a tangent is increasing through the origin, you're all set. You're going to be in great shape. Okay? All right, so let's go ahead and graph out this first one. What we see here, what we're talking about, is the equation y equals 2 tangent x plus 3. So just because it's a tangent doesn't mean that we're going to approach this differently. We still want to know what's the amplitude, again, now I'm putting quotes around because it's not real amplitude, but that's going to help me to build my frame. So what's the absolute value of A? What's the period? What's the starting point? Those are still the first few things that we want to establish. And before that, we better figure out A, B, C, and D. So with your help, please, what is A? 2. What is B? 1. What is C? 0. What is D? 3. All right, good job. Now, once again, A is positive. What does that tell us about whether or not there is a reflection? No reflection. No reflection. Good. All right. It's not real amplitude. This is going to help me build the frame. So vertically, when I build this frame, I'm going to go up and down. Absolute value of 2 is 2. Period. This is a real thing, but we've got to be very careful on our toes. It's not 2 pi over b, just pi over b. So what's my period of this problem? Pi divided by 1 is pi. Then the starting point of this graph. Starting point, still c over b, comma, d. So c over b, 0 divided by 1 is still 0, comma, d is still 3. All right, now guys, I feel like I've kind of gone through that relatively quickly, but are we making sense out of it? Do we see what is happening or what's going on here? So far, yes? All right, so let's go ahead and make our sketch here. All right, go with me on this. Okay, so my starting point, we said, is at 0, 3. So there's the starting point. Now, we begin by drawing our amplitude, quote unquote. It's not real amplitude, but we usually go up the amplitude, down the amplitude. So what we're saying here is our quote unquote amplitude is 2. So for that reason, I'm going to move from starting point up 2, down 2. Now, if this were a sine or a cosine curve, just like what we were talking about a minute ago, we would move to the right the full period. But with tangent, we do it a little bit differently, don't we? The period for tangent actually goes from asymptote to asymptote. So as you can see, the starting point, as weird as this might sound, falls smack dab in the middle of the period, which might sound harder than what we're about to do, but when we're building the frame, what that means is that we're not going to move to the right the full period. We're going to move to the right just half the period. But we're going to then also move to the left half the period. So what did we say the period was a minute ago? Pi. So half the period, wouldn't that just be pi over 2 to the right? Half the period would be negative pi over 2 is how we move to the left. Does everybody see how we're doing that? And then now from here, I know that is a bit of a change, but from here, everything else is going to be the exact same. We're going to cut it in half horizontally. We're going to break it into fourths vertically. Okay, so once we have the frame, remember, we claimed that tangent curves, unless reflected or something like that, but tangent curves, they are increasing or are they decreasing? Increasing, and they go through the origin. So we should fully expect, once again, unless there is a reflection, we should fully expect that we're going to be increasing through the starting point. Okay, so the other nice thing about building the frame, and the reason why we do it this way, is that if we build the frame properly, the left and the right ends of the frame, these edges, these are our vertical asymptotes. So if off to the side we needed to identify, where are our asymptotes located? They'd be at negative pi over 2 and pi over 2. So again, these are on the x-axis, so x equals negative pi over 2, x equals positive pi over 2. Those are answers here. We also want to note that we are increasing. So the reason why we break that into fourths like we do is now we have it. So the other aspect, if you were asked to identify, what's the amplitude of this? What are you going to tell me? There isn't one. Does not exist. Does not happen. What's the period of this one? Yep. All right, so guys, I'm going to circle back, and I'm actually going to change it around a little bit, but I'm going to hit this this cosine problem as well. All right, so wanted to double back and make sure that we get this one recorded. I know that we got through this example in a couple of classes, but not all three. So first thing that we're going to do is we're going to change this. I just don't like the setup of this problem as much as I thought I would with b equaling pi. And that's just not the route that we want to go. So instead, let's just use the example that we had previously, that y equals negative 4 cosine of quantity x plus 3 pi over 2. Once again, if this looks familiar, we've already handled this guy right here. So we're going to go ahead and just take this once again and just put it. We're going to go ahead and add the graph. So we would say that A is negative 4, B is 1, C is negative 3 pi over 2, and D is 0. Not adding or subtracting anything the backside of this. So what that leads us to be able to say, since A is negative, yes, we do have a reflection. Let's see, the amplitude. Again, this is cosine, so yes, it truly does have amplitude. Like to the definition, it would have amplitude. The amplitude is going to be the absolute value of A, so the absolute value of negative 4 is 4. The period for cosine, remember that period is 2 pi divided by B, so 2 pi divided by 1 is 2 pi. And then our starting point, remember C over B, comma D. So C is negative 3 pi over 2 divided by B, which is 1. So negative 3 pi over 2 divided by 1 stays negative 3 pi over 2, comma 0. And there's our starting point. All right, so going ahead and drawing this sketch, drawing this graph. My starting point is at negative 3 pi over 2, comma 0. There it is. My amplitude, we said, is 4. So that means from the starting point, a little more space here, from the starting point, I'm going to move up 4. And I'm going to move down 4. Kind of like this. We also know that we need to move over a period. So the period we said was 2 pi, so I'm going to move over 2 pi. Please note, again, I'm not going to move over until I get to 2 pi. I'm moving over the amount of 2 pi. Also, extend that down. This is a little bit too far. Okay. So once we have that outer frame, that outer rectangle, we have to cut it in half horizontally. So again, horizontal line going through the starting point. And then vertically, we have to break it into points. So that means I'm going to cut it in half vertically, and then I'm going to cut each half in half. So this one is working out very nicely in that it's already on the vertical lines of my graph. So remembering that, slightly off screen here, so remembering that this is a cosine problem, let's just kind of in the back of our mind think through what a cosine curve is going to look like. So if we have a cosine curve, not to be confused with sine. Sine goes through the origin. Cosine does not. Cosine starts 1 unit above the origin, loops down, and comes back up. That is one period of cosine. So for our purposes down here, on a much larger scale, we're going to go ahead and handle this the exact same way. So if you think about our parent function as having 5 key points, here, 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 and here, those key points being maximum points, zeros, and minimum points, those are our key points. That's why we draw in the 5 vertical, or excuse me, we break into the 4 vertical partitions. So if you are doing some counting, we have 5 vertical lines up there. Each of those vertical lines is going to have a coordinate on said line. So under normal circumstances, we would look at this and say, all right, this is just the new origin, my starting point. And just like the cosine parent function does not go through the origin, the cosine parent function, or the cosine curve that we're sketching here is not going to go through the starting point. So instead, we would typically go 1 unit above. But this is not a typical problem because, again, we stated that there is a reflection. So what that means is that up here, in my parent function, everything that was a maximum is now a minimum. Everything that was a minimum is now a maximum. But the zeros do stay the same. So what that means is we're not going to start 1 unit above, but instead we're going to start, colors up here, we're going to start 1 unit below, and then we're going to extend our way through with our vertical lines acting as the spacing that we're seeking here. So once we have our 5 key points sketched in, we need to draw our curve accordingly. So that's what our 1 period is going to look like. To go back and answer the specific questions that you may potentially see, we would want to identify the amplitude, which we already said was 4. We want to identify the period, which we said was 2 pi. The other thing that we may be asked to identify for something like this is the range. So we are always for range going from low to high. So the lowest possible value in this particular problem appears to be -4, while the highest possible value is at +4. So again, we're talking about our minimum points all the way to our maximum points. So -4 to 4, both of which are included. So you'll notice that we are putting the brackets, the inclusion brackets around them. And now we know what the range is going to be. So today we talked about how to graph sine curves, cosine curves, tangent curves. If we stand a chance at doing that, we have to be able to identify A, B, C, and D, knowing that amplitude is the absolute value of A. Period is going to be, for sine or cosine, 2 pi over b. For tangent, it's pi over b. The starting point is c over b, comma d. So remembering also what those parents look like. Again, the parent function for tangent is going to be increasing through the origin. The sine curve, we go through the origin, starts off increasing. The cosine curve does not go through the origin. It starts off 1 unit above. So with that in mind, hopefully we're feeling a little bit better about this stuff. Again, we've got 1 more day to review, and tomorrow we're gonna tackle some practice problems for sure. So good luck. Come see me if you have questions.